Hello everyone. Welcome to this video on learning mathematics through concepts and examples. In this video, we are going to solve Mastery Exercise 6 from your Intro to Statistics class. And the topic of this video is normal distribution. So let's begin with our first example. Example 1. For a standard normal distribution, find the probability that the z-score is less than 2.39. Express the probability as a decimal rounded to 4 places. So here we are talking about the standard normal distribution. So first thing we do is we try to sketch the graph for the normal distribution. So let's do that first. Suppose here is my normal curve. So this is the standard normal distribution, meaning the mean is 0 and the standard deviation is 1. So this is the normal distribution with mean 0 and standard deviation 1. So if that is the normal distribution, along the x-axis, we'll have the z-scores. Z-scores are along the x-axis. So in the middle, we have the mean, which is a 0. And here, we want to find the probability that z is less than 2.39. So 0 is here, so 2.39 should be somewhere there. So we can draw that over here. You can draw a vertical line there and then represent that z value of 2.39. And we want the probability that the z-score is less than that value. So when we say probability, probability is same as the area to the left here because we are looking for z less than. So we are looking for this area. So let me show you the area here. Like that. Okay, now in order to find this area or probability, let me write here, probability that the z value is less than 2.39. Remember, when we want to find the probability, we are using calculator to solve all the problems here, by the way. So to find the probability, we use normal CDF in our calculator. Normal CDF in our calculator. And then what we do is we write the lower boundary for the area and we go up to the upper boundary for the area. So you can see if you look at this area here, the lower boundary is all the way to negative infinity this side. So we write negative, and we don't have infinity in our TI-84 calculator. So for negative infinity, negative, for infinity, we write E99. I'll show you where that is in our calculator. So we are starting here at negative E99 or negative infinity, and we go up to 2.39, 2.39, okay, lower boundary, upper boundary, and then we write the mean, which is 0 in this case, and then the standard deviation, which is 1 in this case. So always remember, if you want to find the area or probability, using TI-84 calculator, then we have to use the normal CDF in our calculator. So we use normal CDF, the lower boundary for the area. So in this case, it was negative E99, then upper boundary for the area, and then we do the mean, okay, and then the standard deviation. So if we use this in our TI-84 calculator, we'll get that area or probability. Now I'm going to show you how we can use TI-84 calculator to get the value of this one. Okay, here is my TI-84 calculator. Now we go to second and then press this vars. And we are looking for normal CDF, which is number 2. Lower boundary in our case is negative infinity or negative E99. E is underneath this comma. So if you place, if you press second and comma, you'll get that E, then 99. But we need negative. So in fact, we need negative in front, so it should be negative, then E9, hold on, that should be E. So if you press second and comma, that's E, then 9, 9. That is negative infinity. Upper boundary was 2.39, 2.39. And because it is the standard normal distribution, mean is 0, standard deviation is 1. And if you paste this, you'll see what you have written in your notebook. See, it's exactly same as what we have written on the notebook. And if you hit enter, you'll get the area, which is 0.9916. Okay, so see, you can look at the writing here or our comment in the calculator from negative E99 up to 2.39, mean 0, standard deviation 1, we got 0.9916. So that is the probability that z-score is less than 2.39. Okay, let's move on to next example. So here is example 2. For the standard normal distribution, find the probability that z is greater than negative 2.55. Express the probability as a decimal rounded to 4 places. Okay. So here also we start by drawing the normal distribution. So let's do that. Suppose that's my normal distribution. This is the standard normal distribution with mean 0 and standard deviation 1, so that we have the z-scores along the x-axis and mean is here, which is a 0. And here we are talking about the z-score, which is negative 2.55. 0 is here, so negative 2.55 should be somewhere there. So we can show that. Okay, suppose that is negative 2.55. And we want the probability, which is same as the area, such that the z-score is greater than that. When we say greater numbers, they are on the right. So that probability is equal to all this area. So let me show you that area. So we are calculating this area. So here we want probability that z-score is greater than negative 2.55. And this is equal to normal CDF. That's what we use in our calculator. Normal CDF, because we are calculating the probability. So whenever we are calculating the probability or area, we use normal CDF. Then we start with the lower boundary for the area. So for this area, lower boundary is here, which is negative 2.55. Negative 2.55. Upper boundary, we go all the way up to positive infinity. Positive infinity in our calculator, we type that as E99. Mean is 0, standard deviation is 1. So now this is equal to, we type this in calculator and find the value. So let's see what we get from our calculator. Okay, here is my TI-84 calculator. We go to second, then vars, and number 2 for normal CDF. Lower boundary is negative 2.55. So we use this negative sign, negative 2.55. Upper limit is, okay, upper limit we have is positive infinity. So E99, if you press second and comma, there'll be E, then 99, that's infinity, positive infinity. That's E99. Let's see. Okay. And then mean is 0 because it is the standard normal distribution. Standard deviation is 1. We paste that in main screen and then hit enter to get the result, which is 0.9946. So we got the probability that z is greater than negative 2.55 as 0.9946. Okay, let's move on to third example. Here is the third example. Here also we are going to calculate the probability again. For the standard normal distribution, find the probability that this z is between negative 2.22 and 0.53. Okay, we are asked to write the answer up to 4 decimal places. Again, we start by drawing the normal distribution. So let's draw that first. Okay, so this is the standard normal distribution with the mean 0 and standard deviation 1, meaning the mean 0 is here, and along the x-axis, we have the z-scores. Now, what we want is, we want the probability between negative 2.22. So negative 2.22 should be somewhere here. From negative 2.22 up to 0.53. 0 is here, 0.53 should be close to 0 on the right. So that should be the value. So let's label them. This one is negative 2.22. And this value, the upper value, is 0.53. And we want the probability between those two values, which is same as the area between those two values, like that. Now, to find the probability or area in TI-84 calculator, we use normal CDF. So that is where we start. So probability that Z is between negative 2.22 and 0.53 is equal to normal CDF, lower boundary for the area, negative 2.22, negative 2.22, upper boundary for the area, 0.53, mean in this case is 0, standard deviation is 1. Now we are going to type this in TI-84 calculator to get the result. Okay, here's my TI-84 calculator. We go to second, then vars, and number 2, Holden. Second, then vars, and then number 2. So now we start typing here. Lower boundary is negative 2.22, negative 2.22. Upper boundary is 0.53, 0.53. Mean is 0, standard deviation is 1, and we paste that in the main screen and hit enter so that we get the probability between those two values, which is 0.6887. Okay, we got the probability as 0.6887. So remember, probability is same as the area. And to find the probability using TI-84 calculator, we use this command here, normal CDF, lower boundary, comma upper boundary, comma mean, and standard deviation. So that is what we did in these 3 examples here. Now let's move on to example 4. Okay, example 4 has 2 parts. Let's see what we are asked to do here. The mass of species of mouse commonly found in house is normally distributed. So here we are talking about a normal distribution with the mean of 20.6 grams. So you can see here, mean is 20.6 gram. That is the mean. And the standard deviation is 0.19 gram. That is the standard deviation. We have to round our answer to 3 decimal places and answer these 2 questions. So let's begin with the first part here. Let's see what we have in A. In A, we have to find 10% of all mice have the mass less than blank grams, or less than how many grams. We have to find that. So let's draw the normal distribution to represent that first. Okay, here is that normal distribution. This is the normal distribution with the mean 20.6 and standard deviation 0.19. Meaning of that is, this is not a standard normal distribution. So the values along the x-axis are not z values. Instead, they are the x values. Okay, the question here is 10% of all mice have less than how many grams? So if you think of the weight is along the x-axis. Here we have 20.6. 20.6. You can see below 20.6, we have 50% weight. And above 20.6, we have another 50% weight. Here we want the weight so that the 10% will be below that. Okay, 10% of all mice have the mass less than how many grams? So if we try to consider something over here, okay, if we want to find that, okay, if you want to find that value, the weight of the mice, or you can say mass, whatever you call it, you have to find this mass so that you have 10% below that. Okay, you have 10% below that. So that means on the tail here, the total area on the tail here will be 10%. Okay, 10% or 0.10 if you want to write as a probability. So you have 10% area below that. 10% of all mice have the mass less than how much? We have to find that M. So now what we have to do here is, if you want to find that M is equal to, whenever you want to find the value along the x-axis, that can be the x value or the z value, okay? And once you know this area, in that case, we use inverse normal in our calculator. Inverse normal. And then we write the area to the left of this M value, okay? So if you see, the area on the left is 10%, area on the right will be 90%. So area on the left, that's what we want, which is 10% or 0.10. Then we write the mean, which is 20.6 in this case, and standard deviation 0.19. So always remember to find values along x-axis. Along x-axis, okay, in a normal distribution. In a normal distribution. So if you want to find the values along x-axis in a normal distribution, you will use inverse normal. Okay, inverse normal, that's what you'll use. And we write the area on the left. That's very important. Area on the left. Okay, area on the left. Area on the left, comma, the mean, comma, the standard deviation. So if we use this comment in our calculator, we will get the value along the x-axis. So let's try to use this one, or let's try to type this one in TI-84 calculator and find its value. Okay, so in TI-84 calculator, we go to second, vars, and here you see in number 3, we have inverse normal. So we take that number 3 and we type the area. Remember, this area is the area on the left. So in our example, area on the left is 0.10, 10% area is on the left. Mean in this case is 20.6. 20.6 is the mean. Standard deviation is 0.19, 0.19. And if you paste this, you will see what you have written on your paper. This is what we have written. And then we hit enter to get the result. So if we enter, we get 20.3565, but we are asked to write up to 3 decimal places only. So it will be 20.357. Okay, so it is 20.357 grams. So we can say 20.357 gram is the cutoff weight for the lower 10% from upper 90%. Or we can say 10% of all mice have the mass less than 20.357 grams. Okay, that is part A. Now let's see what we have in part B. Okay, for part B, 15% of all mice have the mass more than how many grams? So here we are talking about more than, that is, we are looking for the cutoff score for upper 15% from lower 85%. So let's sketch the graph first. So suppose this is my normal distribution. normal distribution with mean 20.6, standard deviation 0.19, mean goes here, which is 20.6. Along the x-axis, we have the x values, which is the mass. And we need 15% of mice have a mass more than how many grams? So we have to find the mass M so that we have 15% above that. Okay, so we have 15% here. Above that, we have 15% or 0.15. Okay, now in order to find this mass M, which is the value, okay, which is the value along the x-axis in a normal distribution, we use inverse normal. Okay, we use inverse normal, and then what we need is area on the left. Here, the area on the right is 15% or 0.15. Total is 100%. So on the left, you have a 15, on the right, you have 15%. That means area on the left will be 85% or 0.85. Okay, area on the left is 0.85 because we need area on the left. Now we need the mean and the standard deviation. Mean is 20.6 and standard deviation is 0.19. So we are going to type this in our TI-84 calculator and get that value. In TI-84 calculator, we go to second, vars, and the number 3 for inverse normal. We need the area on the left, which is 0.85, 0.85, mean 20.6, standard deviation 0.19. If you paste this, you will see what we have written on paper. And if we hit enter, we get the result 20.7969. We are asked to write up to 3 decimal places. So it will be 20.797. Okay, 20.797 grams. So 20.797 is the cutoff score for the upper 15% from the lower 85% weight. So 15% of all mice have the mass more than 20.797 grams. So remember, in this example, we are asked to find the values along the x-axis. Okay, we are asked to find the values along the x-axis. So whenever you want to find the values along the x-axis in a normal distribution, always use inverse normal. And once you do that, your area that you put in your calculator must be the area on the left. Always remember that must be the area on the left, comma, mean, and then standard deviation. Okay, that's the end of example 4. Let's move on to example 5. Here is example 5. Let's see what we are asked to find. A manufacturer knows that their item have a normal distribution length. So length of the item is normally distributed. So here we are talking about normal distribution with the mean of 16.7 inches. So that is the mean given. Okay, and standard deviation 1 inch. If one of the items is chosen at random, what is the probability that it is less than 17.7? We want to find the probability that the length, okay, probability that the length is less than 17.7 inches. We have to find this. So in order to answer this question, first we are going to sketch the graph for the normal distribution. So that's where we are going to begin. Let's sketch the graph. So that's my normal distribution. So this is the normal distribution with the mean 16.7 inches, standard deviation 1. So the value that goes here is 16.7. And what we are asked to do is we are asked to find the probability that the length is less than, now along the x-axis, we have the data value x. And we want to find the probability that the length is less than 17.7. 16.7 is here. So 17.7 will be somewhere here. Okay, maybe that is 17.7. We want to find the probability that the length is less than that. When we say less than, meaning of that is on the left. We have to find the probability that the value is less than 17.7, and probability is same as the area. So we can say the area now. We want to find this area. Okay, now the probability that the length is less than 17.7 is equal to find the probability, we use normal CDF. Normal CDF. Always remember, to find the probability or area, we use the normal CDF in our calculator. Then we start with the lower boundary here for this area. Lower boundary for the area, it goes all the way to negative infinity. In calculator, we write negative E99. Upper limit 17.7. Okay, mean 16.7, and standard deviation 1. So all we need to do is type this in our TI-84 calculator and get the value. In TI-84 calculator, we go to second, then vars, and then number 2 for normal CDF. We are starting with negative infinity or negative E99, which is already here, negative 1 E99 or negative E99, which is same thing. The upper limit is 17.7. 17.7 is the upper limit. Mean in this case is 16.7. 16.7 is the mean. Okay, standard deviation is 1. Now we paste this, which is same as our writing on the paper, and we hit enter to get the result, and we got 0.8413. So probability that the length is less than 17.7 is 0.8413. That means this area is 84.13% of the total area under this normal curve. Example 6. A manufacturer knows that their item have normally distributed lifespan. Okay, normally distributed lifespan with the mean of 8.5 years. Mean life is 8.5 years, and the standard deviation is 1.9 years. If you randomly purchase one item, what is the probability that it will last longer than 5 years? We have to find the probability that their lifespan is greater than 5 years. Greater than 5 years is how much? We need to find that. So in order to solve this, we are going to first sketch the normal distribution. So let's begin by drawing that. Suppose this is my normal distribution with the mean 8.5 and standard deviation 1.9. So mean goes here in the middle, which is 8.5. And along the x-axis, we have the data value x. We want to find the probability that length is greater than 5. So 8.5 is here. So 5 will be somewhere there because the standard deviation is 1.9. So we count like that. So here is our 5. Okay, I can draw the line separating the area below 5 and above 5. And we want the probability that the length is more than 5. More than 5 or greater than 5 is on the right. And probability is same as the area. So we can set and show that area. So as we are calculating the probability, the value of the probability will be equal to this shaded area. So now let's work on that. Now probability that the lifespan is greater than 5 is given by normal CDF, because this is the probability or area, so normal CDF. And then we write the lower boundary for the area, which is a 5. We go all the way up to infinity. So the upper boundary will be E99. That's how we write infinity in calculator. Mean is 8.5. Standard deviation is 1.9. In order to find the value, we type this in TI-84 calculator. In TI-84 calculator, we go to second, then vars, and then number 2 for normal CDF. We start with the lower boundary, which is 5. We go to upper boundary, which is E99. E is under comma, so we press second and then comma for E, and then 9. Mean in this case is 8.5. 8.5. Standard deviation is 1.9. 1.9. We paste this. When you paste, you will see what we have written in the paper, and then we enter to get the value, which is 0.9673. 0.9673. So probability that the lifespan will be greater than 5 years will be 0.9673, which is 96.73% of the total area under this normal curve. Example 7. A particular fruit's weight are normally distributed. So here also we are talking about the normal distribution with the mean of 322 grams. 322 grams is the mean, and a standard deviation of 15 grams. Standard deviation of the fruits is 15 grams. If you pick one fruit at random, what is the probability that the weight is between these two values? So we have to find the probability that the weight is between 284 and 328 grams. So what is this probability? We need to find that probability. So in order to calculate the probability, we start by drawing the normal distribution. That's our first step. So here is my normal distribution. So this is the normal distribution with the mean 322 grams and standard deviation 15 grams. Okay. So here in the middle, we have 322. That is the mean. Along the x-axis, we have different weights, x. We want the probability that the weight is between 284 grams and 328 grams. So now you can see here 322 is here. Okay, 322 is here. So that means 284 will be somewhere below that. So maybe somewhere here is 284. And we go up to 328. 322 is there. So 328 is somewhere there. So suppose that value is 328. So let me draw the line to show that. Okay. We can draw like this. And we want the probability that the weight is between these two values. Probability is same as the area. So we are going to say it like this. Okay, let's say it like that. And let's use TI-84 calculator. First, let me write the comment. Probability that the weight is between 284 and 328 is equal to, okay, it is normal CDF because we are calculating the probability or area. Lower boundary, 284. Upper boundary, 328, because we go from here to here. Mean is 322. Standard deviation is 15. So now, in order to find this value, we are going to put the values in TI-84 calculator. So in TI-84 calculator, we go to second, then we go to vars, and number 2 is our normal CDF. Lower boundary in this case is 284. 284. Upper boundary 328. 328. Mean 322. Standard deviation 15. And we are going to paste this, which look like our writing on the paper. And once you hit enter, we get the probability, which is 0.7673. 6498. So the weight of the fruit between 284 gram and 328 gram will be 0.6498. That means 64.98% of the fruits weigh between 284 and 328 gram. So that is the end of example 7.
Example 8, a population of values has a normal distribution. So we are talking about a normally distributed population with the mean of 150.4 and standard deviation 71.5. So that is the information about the population. Okay, a population is normally distributed. Mean of the population is 150.4 and its standard deviation is 71.5. You intend to draw a random sample of size n equal to 116. So here we are drawing a population, a sample from this population, and the size of the population is 116, which is more than 30. So that means when the population is normally distributed, size of the sample is greater than 30, sample distribution will also be normal. That is something we know from the sampling distribution. And in first part, we are asked to find what is the mean of the distribution of the sample means. So if you remember the formula, mean for the sampling distribution denoted by mu sub x bar is equal to the population mean mu. Okay, it is equal to the population mean mu, which is 150.4. 150.4. So that's your first part A. In part B, we are asked to calculate the standard deviation of the sample means. So we want the standard deviation for the sample means, which is sigma sub x bar, and is given by the formula population standard deviation over the square root of n. Population standard deviation in this case is 71.5. And we divide that by the square root of the sample size, square root of 116. We simplify this using calculator, and we are asked to write the value up to 2 decimal places. So when we simplify this, we get 6.64. So you can see for the sampling distribution of the sample means, the mean is same as the population mean, but the standard deviation will be smaller than that because we are dividing by the square root of the sample size. So standard deviation is reduced. So the standard deviation is 6.64 for the sampling means, whereas the standard deviation of the population was 71.5. Now we move on to example 9. Okay, let's read this. A population has a parameter mu equal to 92.2, standard deviation 11.7, and you want to draw a random sample of size 126. So here you can see for the population, okay, for the population, mean is 92.2, standard deviation is 11.7, and we are drawing a sample of size 126. So you can see that the sample size is greater than 30. So when sample size is greater than 30, whether the population is normal or not, the sampling distribution will be normal. That's something that we know from the sampling distribution. Now in first part, we are asked to find the mean. What is the mean of the distribution of the sample means? So in part A, we want the mean. Mean for the sampling distribution denoted by mu sub x bar, which is always equal to the population mean. And in this case, the population mean is 92.2. Similarly, in part B, we are asked to find the standard deviation for the sampling distribution. What is the standard deviation of the distribution of the sample? So standard deviation for the sampling distribution is denoted by sigma sub x bar and given by the formula sigma over square root of n. Sigma is the population standard deviation, which is 11.7. And we are dividing that by the square root of the sample size, which is 126. Sample size is 126. Now we are asked to simplify this and give answer accurate to 2 decimal places. So if we simplify this using our calculator, it should be 1.04. So one more time, the mean for the sampling distribution of the sample mean is equal to population mean, whereas the standard deviation will be smaller than that. You can see the population standard deviation is 11.7, but the standard deviation for the sample means is 1.04. We get this small because we are dividing the population standard deviation by the square root of the sample size. Now, example 10. A manufacturer knows that their item have length that are skewed right. Okay, so you can see that the population is right skewed with the mean of 12.6. So you can see population is right skewed, not a normal population. Okay, not a normal population. Okay, population is not normal. Mean for the population is 12.6 inches. And the standard deviation for the population is 3.3. If 37 items are chosen at random, this is the sample size n, which is greater than 30. Okay, chosen at random. What is the probability that their mean length, we are not talking about the length, look here, mean length, their mean length is greater than 12.3 inches. So we want the probability that the average is greater than 12.3 inches. So what is this equal to? So here what we know is, since the sample size is greater than 30, the sampling distribution of sample mean will be normal. Okay, whatever the population may be, population can be left skewed, right skewed, or normal. If the size of the sample is greater than 30, the sampling distribution will be normal. That's what we know from the sampling distribution. So we say this: since n is greater than 30, sampling distribution of sample means is normal. That is what we know. So let me draw that normal distribution quickly. Okay, suppose this is the sampling distribution of sample means. Along the x-axis, we have the sample means, and this is the normal distribution with the mean mu sub x bar and standard deviation sigma sub x bar. So let's find these two values. What are these values? So here, mean is equal to the population mean, which will be equal to 12.6. And the standard deviation is the population standard deviation divided by square root of n. That is equal to population standard deviation is 3.3 divided by square root of the sample size. Sample size is 37. So 3.3 divided by square root of 37 is 0.5428. So that means for this sampling distribution, mean is 12.6, which goes here in the middle, 12.6, and the standard deviation is 0.5428. Now, once we know this, we want to find the probability that the mean, okay, mean is greater than 12.3. 12.6 is here, so 12.3 will be somewhere there, very close to that on the left. So that is 12.3. Let me also draw the line to separate the lower and upper value from 12.3. We want the probability that the mean is greater than 12.3. Mean is this values, greater than 12.3 is on the right. And we're looking for the probability, which is same as the area. So we can say this. So probability will be equivalent to this area here. So we say probability that the average is greater than 12.3 is equal to normal CDF. We use normal CDF because we are talking about the probability. So whenever we are calculating the probability or area, we use normal CDF. Okay, normal CDF there. Now we need a lower boundary for this area. So if you look at this area, lower boundary is 12.3, 12.3. Upper boundary, this area goes all the way up to positive infinity. So we write E99. Mean for this distribution is mu sub x bar, which is 12.6. And the standard deviation for this distribution is sigma sub x bar. And we found that value here, sigma sub x bar is 0.5428. Now, in order to find this value, we need to type this in TI-84 calculator. So here in TI-84 calculator, we go to second, then this vars, and then number 2 for normal distribution. Lower boundary is 12.3. Upper boundary, we go to infinity, so E99. If you press second and comma, that's E, then 99. Mean for the distribution, 12.6. And the standard deviation is 0.5428. 5428. And we paste this. When you paste this, this is exactly same as what we have written on paper. And when you hit enter, we get the result. We get 0.7098. So probability that the average length or the mean length is greater than 12.3 inches is 0.7098. So that is the end of example 10 and also end of this video. I hope you find this video helpful. If you like this video or if you find this video is helpful, don't forget to give a like at the end. Thank you so much for watching.